Welcome back to our channel Electron Chemistry Tutorial. I am Vijayalaxmi. Now let us discuss problems on normality. Okay. In before video we have done molarity problems for JEE Mains, NEET, MCET. So in this video we are going to discuss normality. Okay. How to define normality? The number of gram equivalents of solute in dissolved state present in 1 liter of a solution. This is known as simply normality, that is denoted as capital N. Capital N is equals to number of gram equivalents in 1 liter of a solution. Okay. So simply here units number of equivalents per liter. Okay. So simply number of equivalents in liters or number of milli equivalents in milliliters. Clear? Number of equivalents is equals to N into V in liters. Okay. Number of milli equivalents is equals to N into normality into volume of solution in milliliter. Suppose number of equivalents is equals to N into V maybe in ml, so we can take by 1000. Okay, here also same. So we have to find out milli equivalents in maybe liters, we have to take 1000. Here normality formula also written as weight by gram equivalent. GEW means gram equivalent weight of that solute into 1000 by V in ml like molarity. So simply here number of equivalents also equals to weight of that solute by gram equivalent weight of that solute. So that's why instead of En we can write small e and we can write W by GAEW into 1 by V in liters or 1000 by V in milliliters. Okay. Now suppose weight volume percentages are given. So simply like molarity, so it will also changes. Normality is equals to 10 into weight by volume by gram equivalent weight. So here what is gram equivalent weight? There in normality gram molecular weight means simply we can take formula weight of that solute. So gram equivalent weight nothing but, see here gram equivalent weight or simply equivalent weight capital E is equals to formula weight or gram molecular weight of that solute by its valency. So valence simply you can take small n. So this valency nothing but basicity of that acid. Suppose you can take bases, you can take acidity of that basis, acidity of that base. So maybe salts are given, charge on the cation, total charge on the cation or positive ion or negative ion. Okay. So simply suppose oxidant reductants are given. So number of transferred electrons, number of transferred electrons nothing but increase or decrease in oxidation number. Okay. Suppose for example you can take any acid. Suppose one acid you can take here HCl. So for HCl equivalent weight of HCl is equals to formula weight of HCl how much? 36.5. 1 per hydrogen, 35.5 for chlorine. 36.5. How many hydrogens? 1 hydrogen. Here you can take number of replaceable hydrogen atoms. Okay. So number of replaceable hydrogen atoms nothing but, see here suppose that hydrogens are connected with more electronegativity atoms like fluorine, chlorine or nitrogen or oxygen. Okay. So these all are what? More electronegativity atoms. So these hydrogens only replaceable by the what? Metal ions. Okay. Suppose you can take here H2SO4. Okay. So here what is the structure of H2SO4? Tetrahedral structure. So here 2 hydrogens are replaceable with metal ions. So that's why basicity of that acid 2. Suppose you can take phosphoric acid. H3PO4. See here number of replaceable hydrogen atoms 3. So you can take what? 3 is a basicity of that acid. Suppose phosphorus acid H3PO3. What is the structure? OH, OH, H. Okay, number of replaceable hydrogen atoms only 2. So here base city taken as 2. So here base city taken as 3. Okay, so simply equivalent weight of HCl 36.5 by 1, only one hydrogen, the replaceable hydrogen. So suppose H2SO4 equivalent weight of H2SO4, formula weight of H2SO4 how much? 2 plus 32 plus 64, how much? 98. Okay, so by how many hydrogens? 2, 49. Clear? Now here formula weight of phosphoric acid, 3 plus 31 plus 64, again 98 by how many hydrogens? 3. Okay, so now here formula weight of phosphorus acid 82, 2 hydrogens are replaceable, so base city is 2. Okay, so in this way you can find out gram equivalent for acids. Okay, so we can take base city of that acid. Base city means number of replaceable hydrogen atoms present in that acid. Clear? Suppose basic solutions are given. So how to find out equivalent weight? So we can take acidity of that base. Suppose here, suppose you can take any base NaOH. Equivalent weight of NaOH, formula weight of that NaOH how much? 40 by number of replaceable OH groups. OH groups nothing but acidity of that base. So 140 only. Okay, suppose you can take calcium hydroxide. Okay, so here how much? 40 plus 16 2s are 32 plus 2. How much? 74. 74 by how many replaceable OH groups? 2. So how much? 37. Okay, now suppose any salts you can take. Equivalent weight of any salt is equals to formula weight of that salt. Salt suppose NaCl you can take. So 23 plus 35.5, how much? 58.5 by, so a number charge on the cation or charge on the anion, only one. Okay, suppose you can take oxidants. Oxidant, what are oxidants? KMnO4 act as oxidant, K2Cr2O7 act as oxidants, means reduces itself. Okay, next here KMnO4 in acidic medium get converts into here central atom in acidic medium, it converts into Mn plus 2. Here plus 7 oxidation state 2 plus 2. So how much decrease in oxidation number? 7 minus 2, 5. So then simply equivalent weight of KMnO4 in that acidic medium, what? So simply 158, formula weight of KMnO4 158 by 5, 31.6. Okay, in basic medium it converts into K2MnO4. So plus 7 to plus 6 oxidation number, change in oxidation number 1. So simply you can take equivalent weight of KMnO4 in basic medium 158 by 1 only. So in a neutral medium, so it will be changes to MnO2, means plus 4 oxidation number, 7 minus 4 is equals to 3. So in a neutral medium equivalent weight of KMnO4 is equals to what? 158 by 3 only, 52.6. Okay, next you can take reductant. So reductant, some more salt is reductant, more salt. Here ferrous ammonium sulfate is a more salt. Here Fe plus 2 get converts into Fe plus 3 only. Change in oxidation number 3 minus 2 is 1. So simply here what? Equivalent weight of more salt formula weight 392 by 1 only, 392. Okay, so in this way we have to calculate this gram equivalent weight. The resulting value is substituted here to get normality. Okay, now for dilution we can use same as molarity, N1 V1 is equals to N2 V2. Okay, So for mixtures, same kind of mixture means same nature of compounds, means maybe acids or maybe bases are mixed together. So we can find out total normality of that solution is equals to N1 V1 plus N2 V2 so on by V1 plus V2 so on. Okay. For different kind and different nature of compounds are mixed together, maybe acids and bases mixed together. If both concentrations are same, that is neutral solution. So if concentration of acid is more than the NaVa more than the NbVb, the resulting solution is acidic medium. So for that we can find out normality with respect to H plus ions is equals to NaVa minus NvBb by Va plus Vb. Clear? Next, if acidic nature is less than the basic nature, the resulting solution is basic. So when we have to calculate normality with respect to hydroxyl groups, OH minus groups, so then NbVb minus NaVa by Va plus Vb. Okay. For titration and neutralization reactions, we can use both formulas based on the conditions. So if only concentrations and volumes are given, so we can take simply N1 V1 for first solution, N2 V2 for second solution. First solution neutralizes with second solution, we can find out the titration. Okay. So we can find out that molarity or volume of given solution. Okay. Suppose weight involved in that question. Suppose how much weight of that acid or base neutralizes particular volume of acid or base with particular normality. So in that case we can use this formula, weight of acid by gram equivalent weight of acid is equals to normality of base into volume of base in milliliters by 1000, or weight of base by gram equivalent weight of base, that is equals to normality of acid volume of acid in milliliters by 1000. Okay. If weight of that acid or base involved in that question, so we can use these formulas. Otherwise we can use simply N1 V1 is equals to N2 V2 for neutralization. Clear? Now molarity normality interrelation. Normality is equals to molarity into N. N means here basicity of acid, acidity of base, charge on the cation or anion for salts, number of transferred or increasing, decrease in oxidation number for oxidant or reductants. Clear? So this is what important formulas for normality. Okay, let's do some important objective bits on the normality. Clear? Let's start. First problem on normality. Number of milli equivalents of solute present in 100 ml of 0.2 N solution. So we know very well number of milli equivalents means NEQ is equals to normality into volume of solution in milliliters. Okay. Normality is given as 0.2, volume is given as 100 ml. How much? 20 milli equivalents. Clear? This is the answer. Next, molarity of 2N H2SO4 solution. So normality is given as 2, we have to calculate molarity. What is the relation between them? Normality is equals to molarity into N, or molarity we have to calculate, no? So that's why normality by valency of that acid. Okay. So simply here M is equals to normality is given as 2, basicity of that acid how much? H2SO4 structure S double bond O, OH, OH, S double bond O. So number of replaceable hydrogen atoms 2, that is simply basicity of that acid, nothing but that is valence. So simply how much? 1 moles per liter. Clear? Now the normality of 0.98 weight by volume percent of phosphoric acid. Simply, normality, what is the formula of normality? When weight by volume is given, simply normality is equals to 10 into weight by volume of that solute by gram equivalent weight only. 10 into weight by volume is given as 0.98 by gram equivalent weight of what? Phosphoric acid. H3PO4 is equals to formula weight or gram molecular weight by basicity of that acid. Basicity of that acid. Okay, formula weight how much? 3 plus 31 for phosphorus. Each oxygen how much? 16 4s 64. So then how much ma? 98 only. Okay. So the 98 by basicity of that acid. What is the structure? 1, 2, 3. 3 moles. 1s 3 3s 9. How much? 3 2s 6. 2 6 32.6. So here 32.6, 9.8 by 32.6. By simplifying this, we'll get 0.3. Clear? Next, see here fourth problem. The volume of 0.0 n NaCl solution required to neutralize 100 ml of 0.001 m phosphoric acid. Simply, sodium chloride neutralizes phosphoric acid. Okay, so what is the formula for neutralization? N1V1 is equals to N2V2. Okay, now for first solution, NaCl solution, so normality is given as 0.01. We have to calculate volume of that NaCl V1. Next, required to neutralize 100 ml of phosphoric acid with 0.001. So here molarity is given. So then simply normality is equals to molarity into N. Molarity is 0.001. N means per phosphoric acid basicity how much? Number of replaceable hydrogen atoms 3. Okay, 3. So simply instead of N2 we have to write this one, simply 0.003. 0.003 into volume 100 ml. Okay. Now V1 is equals to here 0.3 by 0.01. How much? 3 into 10 only, that is nothing but 30 ml. Okay, so 30 ml of NaCl required to neutralize phosphoric acid here. Clear? So now this is also neutralization problem, but here weight is involved. Listen to me. A tablet of vitamin C is analyzed for its ascorbic acid content. One tablet reacts exactly with 20 ml of 0.1 n NaOH solution. So the equivalent weight of ascorbic acid is given as 176. The tablet contains dash milligrams. Okay. So we have to calculate weight of the tablet. Means tablet C vitamin tablet, that is ascorbic acid. Simply weight of acid means ascorbic acid by gram equivalent weight of ascorbic acid, that is equals to base, normality of base NaOH, volume of base, that NaOH by 1000. We have to calculate this weight. You can take as simply W. W by GMW is given how much? 176. That is equals to Normality of base given as 0.1. Volume of base given as 20 ml by 1000. By simplifying this, 0.1, 0 cancel, 2 means 0.2 only, 10 power minus 2 into 176. 2 into 10 power minus 3 into 176. 2 6 12, 7 14, 15, 2 1 2, 3. So this is what grams, but we have to calculate in milligrams. Milligrams nothing but 352 into 10 power minus 3 into 10 power 3 milligrams. 1 gram, 1 milligram is equals to 10 power 3 grams, no? Okay, so simply 10 power minus 3, 10 power 3 mutually cancelled, simply 352 milligrams. Clear? Next, sixth problem. So it is similar to before problem, fifth problem. So see, I will give you a hint and you have to do it, ma. Okay, and write the answer in the chat box. Okay, so first of all, weight of KMnO4 we have to calculate. That can oxidizes 100 ml of 0.4 N oxalic acid in acidic medium. Okay, what is the formula? Weight of compound means which compound weight we have to calculate? KMnO4 by gram equivalent weight of that KMnO4. Okay, is equals to normality of oxalic acid, volume of oxalic acid by 1000. Clear? Then you have to calculate equivalent weight of KMnO4. So simply here KMnO4 in acidic medium converts into Mn plus 2, no? As I before said. Okay, so here plus 7 to plus 2. How much? 5. So simply equivalent weight, gram equivalent weight of KMnO4, formula weight is given as 158 by 5, 31.6. So this 31.6 right here, and Na is given as 0.4, Va is given as 100 ml 1000. So then you can simplify, you will get answer. Okay, next. So this is homework. Next problem, 100 ml of 1 molarity of H2SO4, 200 ml of 2 normality of HCl, 300 ml of 3 normality of HCl are mixed and made up to 1 liter. Then proton concentration in the resulting solution. So simple, nothing but proton concentration, nothing but normality with respect to H plus ions. Okay, so that is equal simply N1 V1 plus N2 V2 plus N3 V3 by total volume made up to 1 liter. So instead of V1 plus V2 plus V3, you have to take total volume capital V only. Okay, now so N1, for N1 is given, not given, so molarity is given, so that is converted into normality. Normality is equals to molarity into basicity of that acid. So molarity is given as 1, H2SO4 basicity how much? H2SO4 basicity how much? 2. So simply 2. So simply here 2 into 100 plus 200 ml of 2N means normality 2 into 200 plus normality 3 into 300 by total volume 1 liter means 1000 ml. 1000 ml. Okay, that is equals to 200 plus 400 plus 900 by 1000. Okay, 1500 by 1000, that is equals to 1.5 N. Total normality is, so proton concentration or total normality of the resulting solution 1.5. Clear? That's all for this video. So in the next video we will do mole fraction and molality. Okay, so did you like this video? Please like, share this video and subscribe my channel to get more videos. Thank you for watching this video. Thanks a lot.